This is a reminder that you should feel free to take as much time as you need to write all of the notes down and think about them. Pause the video at your own pace.
Welcome everybody, this is section 4.5, day 1, graphing polynomial functions. We've got some terminology to go over. Check it out. I'm going to take this middle example first. F of x equals 4x squared minus x plus 3. We can say because of this highest exponent is 2, we know it's a quadratic function. In fact, the degree, we'll call this 2 because the highest exponent is 2. And the leading term is 4x squared. That's the term that has the highest exponent. The leading coefficient is 4. That's just the number out in front of that highest exponent term. In general, we can say things like this. The constant function would have no x term. F of x equals 3, that would have a degree of 0 because you could think of it as like 3x to the 0. The leading term would be 3 and the leading coefficient would be 3. A linear function would just be one that makes a straight line. That's, for example, 2/3 x plus 5. The degree would be 1 because there's a hidden exponent of 1 here. The leading term would be 2/3 x because that's the term that has the highest exponent. And the leading coefficient would be 2/3. It's a number that's in front of x. We already talked about this one. A cubic function could look like this, and that would have a degree of 3 because the highest exponent is what gives it the degree. The leading term is the x cubed. That's the term that does have the highest exponent. And the leading coefficient is 1 because there's an invisible 1 in front of x cubed. A quartic function would look like this. Negative x to the 4th. The degree is 4 because that's the highest exponent. You could have a leading term of negative x to the 4th and a leading coefficient of negative 1 because that's the invisible number that's out in front. We need to know all these things because we need to be able to analyze a function, and if you know the degree of a term and if you know the leading coefficient, then you can determine what's called end behavior. It's the end behavior is the behavior graph as x goes to positive infinity and negative infinity, like this. Now I realize that this chart right here is actually probably too small for you to fill in, so I would encourage you to take the part that I've written and maybe write it on the side or something like that. But anyway, end behavior is basically the idea that there might be a whole lot of weird stuff going on in the middle. You know, when you plot a graph, it goes up and down and up and down, and maybe just pauses for a minute and then continues to go down. But eventually, it'll just continue to go up. If you just ignore the weird stuff, the oscillating stuff in the middle, eventually it'll either go up to positive infinity as x goes in those directions, or it'll go down this way and down this way. It'll go up this way or down this way. It'll go up or down. You basically have 4 options. Now, and they look very much like the graph of y equals x squared here. Like the simplest version of this kind of end behavior is y equals x squared. Or if you had y equals negative x squared, it would look like this. It would be going down. That's the simplest version of this case. The simplest version of this case would be something like y equals x cubed, where there's nothing in the middle. It just goes up and then down on this side. Up on this side, down on this side. The simplest version would be y equals negative x cubed. If you think about it, actually, the simplest version for these odd cases right here might be y equals x to the first power, a straight line. Y equals x would go like this, y equals negative x would go like this, but you get the idea. And if you don't, just ask me a question tomorrow in class. Anyway, if you have, as it turns out, it's not just the exponent of 3 here, but any odd degree. So if y equals x to the 5th would also look like this. Y equals x to the 7th. Y equals x to the 9th would also look like this. Similarly, y equals x to the squared is the same thing as y equals x to the 4th, to the 6th, to the 8th, to the 10th. Y equals x to the 20th would look like this. It would have up, end behavior. So really what you've got to do is in order to figure out end behavior of a function on a graph, all you really need to know is the exponent, is the degree going to be even or odd, and is the leading coefficient going to be positive or negative? Like this. Here, in this function, you see the degree is even, because 4 is even, and the leading coefficient is positive, 3 is positive, and therefore we can say that this is going to be very similar to the graph of y equals x squared when it's when you're talking about just end behavior. And which one is that? That's this. The polynomial function in A is going to have up end behavior, and that's what D has. It has up end behavior, so therefore, without doing anything else, just looking at end behavior, I can know that A is matched with D. B has -5 as a leading coefficient and 3 as a degree, so therefore odd degree, negative leading coefficient, that's going to be very much like y equals -x cubed, which is up-down end behavior. Which one looks like that? That's B right here, up, down. I can match this polynomial function with this graph, and there it is, B. C, I can say that it matches with A because we've got a odd degree and a positive leading coefficient. Therefore, it'll have the same end behavior as y equals x cubed. That's down, up end behavior right here. I want you to do D. You can do it probably by process of elimination. Sorry, this D, I want you to do polynomial function D matched to the graph. I'm sure you can use process of elimination, but I want you to also to think about it in terms of end behavior as well. And as we can see here, I wrote it out as a table. 3x to the fourth, 4 is even, that's the degree. 3 is positive, so therefore it's going to have up end behavior. One thing to know is that in your textbook, they're going to give you one way they're going to make it a little trickier is they're going to transform your functions. So for example, they'll have this, instead of just saying x to the fourth, they'll say x minus 2 to the fourth. But we know that since 2 is a horizontal shift of 2 units to the right, then it's not really going to affect the end behavior. At the end of the day, it's still going to be an up end behavior. So this is the same thing as the untransformed one, y equals 2x to the fourth, which is still up. Here, we've transformed it to the left 1 unit, not a big deal. The coefficient in the front, the leading coefficient is negative. The degree is even, so therefore it's going to have down end behavior. Here, transformation, it's shifted to the left 1 unit, it's shifted down 1 unit, no big deal. That would be really just the same as y equals 1/2 x squared, which has the same end behavior as y equals x squared, which is up end behavior. So that's your lesson. I want you to start on 4E1, and your presidential audio check president is President Nixon. Nixon single-handedly ended the Cold War. However, he also had a lot of other problems as president. So tell me about Nixon when you get to class. Start assignment 4E1, copy the problem list, and do the first problem, and I'll see you in class.